वर्किंग प्रिंसिपल ऑफ पीवी सेल। तो अब हम ये देख लेते हैं कि बेसिकली जो पीवी सेल है उसका वर्किंग प्रिंसिपल क्या है और एक पीवी सेल किस तरह काम करता है। बेसिकली वेरी एट वेरी हाई लेवल जैसे हम पढ़ चुके हैं, समझ चुके हैं कि सोलर एनर्जी कन्वर्ट करनी है हमें इलेक्ट्रिकल एनर्जी, एंड दैट्स बेसिकली कन्वर्टेड मोर लाइक बैटरी सिस्टम्स। जैसे बैटरी में पॉजिटिव प्लेट है, नेगेटिव प्लेट्स है, बीच में इलेक्ट्रोलाइट्स है, तो और इट्स बेसिकली क्रिएटिंग अ डीसी पावर। सिमिलर टू दैट द आपके पास जो सोलर सेल है, इट्स बेसिकली हैव एन पॉजिटिव प्लेट, नेगेटिव प्लेट, बट except electrolyte, this is now you can say behaving quite similar to the capacitor. So एक साइड पे इसके पॉजिटिवली चार्ज एटम्स होंगे और होंगे जिनको हम कहते हैं आयोन्स। सो वो एटम्स जिसमें इलेक्ट्रॉन कम है एज कंपेयर टू द प्रोटॉन्स इन द नेटवर्क्स, दीज आर कॉल्ड आयोन्स। और जिसमें इलेक्ट्रॉन कम है, दैट्स कॉल्ड पॉजिटिवली चार्ज आयोन एंड नेगेटिवली चार्ज आयोन्स। So if we talk about the atomic structure, so we have a nucleus where we have neutrons and protons, and then we have orbits. Okay, so then we have orbits. So all the atoms, for example, have similar number of protons and neutrons, protons and electrons in their atomic structure. That means the total positive charge and negative charge of an atom is the same. It means that the atom is in the neutral state. Similarly, the electrons, if the outer layer of the electrons tend to have complete 8 electrons in their orbit. So for example, if you have two atoms, one atom has 3 electrons in their orbit, another atom has 4 electrons, 5 electrons in the orbit, then both want to complete their orbit, they both want to become stabilized, these both are unstabilized, these are neutral but these are unstabilized, so they can make a bond and they can be combined, and where you can see the total orbiting electrons across these two will become 8. So it means you can see the octet is now complete and the bond has been established. So if an atom loses one electron, then overall positive charge become more than the negatively charged electrons. So the overall charge for this atom will become positive, and we will call it not now atom, but we call it as an ions. So this is a positive ion, and where we have a more electrons as compared to the protons in the atom, so that will be called as a negatively charged atom, or we can call it its ion, which is negative ion. So we know about the positive ions, we know about the negative ions, we also know about the principle of octane, that atoms tend to complete their outermost orbit by 8, and that's why they want to do bonding, and they form, and they basically made the different molecules. So when two atoms join, they are making molecules. Okay, so like H2O is a molecule, so we have two hydrogen atom and one oxygen atom combined. Next thing is the very basic principle. So if we have one electron in an orbit and it's getting energy, it will be excited. It is every orbit has an energy level. So if electron gains from outer side any kind of energy, this electron will be excited. If energy is enough, then it will jump into from this orbit to this orbit. So it means that if the electron acquired energy, that's basically the difference of the energy of next orbit, then it will jump, he will leave this orbit and will jump to the next orbit. So this is the working principles that we need to understand when we are going through these PV model systems. So coming back to the working principle of PV, so photovoltaic cell is a semiconductor device that converts sunlight directly into electricity through the photovoltaic effect. So what is the key concept? Key concept is the sunlight that has photons in it. When it strikes to the surface of the PV cell, the electrons become excited, and these electrons are then collected to the plates, and then basically these are forming the flow of electrons and electricity through the PV cell. So what is there in the PV cell? So PV cells basically are made up of silicon material. Usually mostly they are using a silicon material, but the silicon has as we know that it has an 4 electron is available in its outermost shell. So what is the formula of power then? P is equal to V into I, whereas P is equal to the power in watts, V is a volts, and I is amps. So we are using silicon. So we are using silicon mostly for as a semiconductor material. So silicon has total 14 you can say shells in it. 14 electrons are available in silicon, and arrangement is in such a way that total 4 electrons are available at outermost shell. So if I make a structure of atomic structure of silicon, it has 14 electrons, and at the outermost shell it has 4 electrons. So it has 4 electrons in the outermost shell, and in the center it has a nucleus that has protons and neutrons. So if I combine two different silicon atoms, so then in that case you can see if I make the structure here, so if 4 electrons from this and 4 are from this, then you can see these two will be in sharing. So it means that if I keep on adding the silicon atoms, so the 4 and 4 electrons at the outermost shell of the silicon atoms will be share, and they will be forming 8 electrons. So 8 is you can say inert state where there is no space of adding or removing any electron from the shell. So 8 is a complete state overall, and you can see here this is example of this complete state with silicon. You can see is shown here by nucleus blue color, and each you can see in orbit has total 1 2 3 4 5 6 7 8 electrons. So one silicon atom is bonded with 4 other silicon atoms, and it is sharing 1 electron with one of the each silicon atom. So this is the structure for a stable silicon. If you have stable silicon, electrons are complete, but in order to energy to flow, in order to energy to flow and for the power flow, we need free electrons. So we will add a material. We have to add a material that must have 5 electrons in it. So if I add a material that have 5 electron in it, so silicon at one side will have 4 electrons, and if I add another material that has 5 electrons, so result will be there will be 1 extra electron available in the orbit that will be free to travel once it is excited by the energy. So here you can see we will add here a element, then element here phosphorus that has 5 electrons in its outermost shell, and here you can see this is a phosphorus shown by red color. It has 5 electrons in outermost shell, and you can see the one electron is now free. So as soon as photons basically interacting with this electron, it will excite it, and it's very easy to move these electrons from the plate from this PV cell. So we have added impurity in the silicon that has 5 electrons in its orbit, outermost orbit or outermost shell. That's created one free to move electron, and this method, this process is called as doping. So we have doped the silicon with the phosphorus atom, and we add this impurity that resulted in a n-type silicon material that has one electron available, that's quite free to get excited and generate electricity. So one side of the plate here finally is n-type that have free electrons available in them. So they have some free electrons. I have added the impurities. Then this is creating a positive negatively charged, you can say negatively n-type silicon material. Here electron can, when the sunlight strikes, so these are moving, they will move up and they will be collected by this plate, and then you can connect a load here, and then now you need to create a positive plate as well. So if you want to create the positive plate, first of all you will add a p-n junction in between them. So I will add a p-n junction, then I will create the positive plate. Positive plate, here you can see, in order to create the positive plate, I need to create an orbit that have not the 8 but 7 electrons. So I will add a material impurity in the silicon that must have 3 electrons in its outermost shell. It means when this impurity combines with silicon, there will be a deficiency of 1 electron in the outermost shell. So this molecule will try to get this electron from any place. So this material is now seeking electron, and this material is an extra electron in its orbit. So they want to get rid of this electron. So I have to add boron here. For example, I have added a material boron that has 3 electrons outermost shell. So you can see there is one deficiency of electron in the last most orbit. That's basically deficiency. You consider this one as a positive charge. This hole you can consider as a positive charge because it is attracting positive, as we know that positive charge attracts the negative charge. So you can see this hole basically attracts because of the atomic structure, nature of this atomic structure. It has 7 electrons in outermost shell, so it's now seeking its electron to be filled here to make it stable. So this type of material is called as p-type material, where we are adding boron and here the n-type material we are adding phosphorus. Phosphorus has 5 electrons in outermost shell, boron has 3. So when it combines with silicon, so you can see 5 plus 4, 1 is additional, and if we combine boron with silicon, 3 plus 4, 1 has a deficiency. So we are calling it as a positively charged atom. So you can see we have now positive and negative charges. So when the electrons are not excited, so these will be gathered across the plates. So we have negatively charged electrons, they wanted to shift to this, but in between that we have put a p-n junction that's stopping them to travel through these plates and attracting them as well. So when the simple principle is, now you have a load, and when the light ray strikes this photovoltaic cell, these electrons get excited and then they are move up, and then these are collected at this plate. Positively charged electrons are now excited and ready to travel, they have energy, and then when it passes through this electron, then this load, this side, they are attracting the negatively charged electrons because the outermost shell is incomplete. So the electron will come here, and in this manner you can see electricity is able to flow. So this is the working principle for the PV. So combined together, you can see here the sunlight is basically coming and passing through this anti-glare glass. So what is an anti-glare glass? Anti-glare glass is a glass that basically has a minimum reflection. As we know that when sunlight passes through the glass, some part of the sunlight is passes through the glass and some part is reflected back to the same media like air. So for the photovoltaic cell, special layer is coated at the glass that's called as anti-glare layer. That function is to make the light to maximum absorb in the cell. So that's basically increases the efficiency of the cell as well. So आप ये देखें कि ये लाइट यहाँ आई, इस पर स्ट्राइक की, यहाँ से इलेक्ट्रॉन्स जनरेट हुए, फिर वो आपके पास फ्लो हुए इस सेल के थ्रू और ये रोटेट हुए, जिसकी वजह से हम जैसे हमने बताया 0.5 to 0.6 वोल्ट पर सेल वोल्टेज जनरेशन होती है तो इतने वोल्ट बेसिकली जनरेट हो गए. So you can see in this way, in the center we have this depletion layer, we can say, or p-n junction. और अगर आप सेल में देखें तो आपको बीच में सेल के अंदर ये पट्टियां बनी हुई नजर आती हैं. बेसिकली दीज आर मेटालिक कंडक्टिंग स्ट्रिप्स जिनके जरिए ये इलेक्ट्रॉन्स कलेक्ट होते हैं और फिर वो आगे टर्मिनल्स के थ्रू ट्रांसफर हो जाते हैं टूवर्ड्स द लोड. जैसे ये है आपके पास, तो ये बेसिकली इसमें जो लाइंस हैं, these are strips to collect the electrons from n-type material. So n-type material टॉप पे है जहां आपके पास लाइट इंटरेक्ट कर रही है. p-type material इसकी बैक साइड के ऊपर आफ्टर द p-n जंक्शन आ जाता है. तो इस तरीके से ये जो आपका सेल है सो वर्कआउट कर रहा है. सो बेसिकली आपके पास जो पीवी स्ट्रक्चर है उसमें आपके पास एंटी रिफ्लेक्टिंग कोटिंग आ गई पहले, और उसके बाद आपके पास एन टाइप सिलिकॉन मटेरियल आपके पास आ गया जो कि इंटरेक्ट करेगा लाइट से, and it will collect energy, electrons will collect energy from photons and then they will be collected at the plate. So it has a nickel plating, and then we have p-type material. P-type material silicon, both are silicon, but one is p-type, one is n-type. So p-type material is down and then p-type material is connected to the negative plate and it's connected to the load. Then we have you can see front contact transparent conductive layer allows lighting to pass while collecting the electrons. N-type layer is rich in electrons. P-type layer is basically where electric field is formed. P-n junction is where electric field is formed. P-type layer has electron holes, positively charged carriers, and then we have back contact completes the electrical circuits. So ये देखें कि ये आपके पास P टाइप है और ये आपके पास N टाइप है. N टाइप मटेरियल दैट हैज नेगेटिवली चार्ज इलेक्ट्रॉन्स, ये फ्लो हो रहे हैं, बल्ब जल रहा है, फिर यहाँ से यहाँ वापस आ रहे हैं, यहाँ ऐड हो रहे हैं, और फिर यहाँ आके फर्दर फिर p-n जंक्शन के थ्रू फिर ये वापस ट्रांसफर का प्रोसेस पूरा चलता रहता है. तो एक्साइटेशन क्या करती है? फोटोन ट्रांसफर एनर्जी टू द इलेक्ट्रॉन्स. Separation electric field at the p-n junction drives electrons to move. Collections electrons flow through the external circuitry, usable electric circuit. Type of current produced is a DC current. तो at the end हम जो है ना अभी एक वीडियो देखते हैं जिसमें हम देखेंगे कि PV सोलर सिस्टम्स इसकी अच्छी एनिमेशन है, वो किस तरह काम कर रहा है.